We're going to start proving triangles congruent. This first part, we're not going to do it in a formal way. We're just going to show how you can use those shortcuts to do it. So if we look at this first example, we are given some information. First, we are given B is the midpoint of AC. Well, that gives me those two things are congruent, right? By the definition of a midpoint. Then we have CD and AD are the same. Okay. Do I have a third side? Because right now we're using the side, side, side. In general, you would look for a third side, a right angle, or another angle. But do we have a third side here? Yes. By the reflexive property. We had this by the reflexive property, right? So, since I had this by the reflexive property, I had these two triangles are congruent by side, side, side. So I may go triangle ABD. It doesn't matter the first one you do. It's congruent to triangle. A is the 1 and the 2, so C. B is, in this case, the same B. D by side, side, side. Okay, it is just a reflection, right? So we just look at the givens, we label the diagram. We'll go over formal proofs later on. All right, let's look what we have here. Now we're doing side angle side. It says, what other information do you need to prove these two triangles by side angle side? Well, they give you these two. They share this by the reflexive property. What would I need for side angle side? I have three angles to choose from. If I said E and G, E would give me angle side side. That doesn't work. Side angle side says I need the included angle. There's two sides. There is my included angle. There's two sides. There is my included angle. So I would need angle EFD to be congruent to angle FDG. And then I would have side angle side. Okay. Let's look here. What would I need for side angle side here? Well, I have these two angles, and they share this side. It needs to be the included side. So if I went side angle, here's the included side. So I would need LE congruent to NB. That's what I would need. Now, most of the questions we're going to work on is not what do you need. It's going to be, here's information given to you. Use the given information. Prove the triangles are congruent, right? This was just a procedure in seeing how side angle side works. Okay. Now we're going to angle side. Is that the included side or the non-included side? Correct, the non-included side. So let's mark up what they give us. We got R and G, and we have W and N. Well, to be angle side, angle side, angle side, I can say JW is congruent to DN. That's what I would need. Or, right, it can be more than one. Angle side, angle side. So I could have had JG congruent to DR. Okay, either one of those would give me the angle side, right? You need two angles and a non-included side. You don't need all four of these. You only need three. You need two angles in one of those sides. Angle side angle, side angle. We need the included side. As you see here, we have, oh wait, this is side angle side. This is side angle side. So let's just improvise. What would we mean to do to make this angle side angle? Okay. Let's say, get rid of this. Let me get rid of this. Which angle do we need? Which angle would we need to make this angle side angle. I just forgot to delete that one. We would need M and H. Now it's angle side angle. So R goes with V. See how it's one tick mark, one tick mark? N is the 2, so that goes with H. See, it connects to one side, it connects to one side, and then the last thing would be T. And that is angle side angle. Now, did we rotate, reflect, or translate? Well, to reflect it, I don't think so. But if I rotated this, if I brought this, that would rotate there. That would rotate there, and that would rotate there. We did a rotation. And when you rotate or reflect or translate is just shift, the triangle doesn't change its shape. There are going to be several problems like this that I want you to go through and solve out, okay? Complete those, turn it in, and then we will start on these formal proofs in class.